In this new episode of my Frontiers of Research series, we learn about the hydrological cycle and how it's influenced by climate change. This seminar was led by Wenxia Zhang, a postdoc at the Chinese Academy of Sciences. Her research largely focuses on modelling of climate change and how it will affect temperature and precipitation throughout geographical space and the implications of it. The hydrological cycle can be thought of as the natural water recycling system on Earth. As a result of solar radiation, water evaporates or biologically transpirates and rises into the atmosphere. This vaporous water, or steam, on rising is cooled, condensed, and returned to the land and sea as precipitation or rain, collecting as surface water that can shape the land and soil, responding to and also forming topography. Water can also penetrate the ground and moves downward through incisions, forming aquifers. Finally, a part of the surface and the underground water leads to the sea. During this trip from land to air to land to sea, the air is converted to gas, liquid, and solid. Processes that form the hydrological cycle can happen in a blink of an eye or over millions of years. The hydrological cycle is intimately linked with the changes in atmospheric temperature and radiation balance as a result of water's ability to transition between gas, solid, and liquid. The warming of the climate system in recent decades is unequivocal, as it is now evident from observations of increases in global average air and ocean temperatures, widespread melting of snow and ice, and rising sea level. In addition, it is expected that the hydrological cycle will be affected by climate change, altering the variability of each component that forms the full cycle. For example, hydrological cycle may be enhanced with more precipitation, more evaporation, but extra precipitation distributed unequally in a country, increasing the likelihood of flooding events in some areas and significant reductions in precipitation in other areas, causing drought. Climate change looks to present increasing variation in the timing of wet and dry seasons, which impact on everyday lives, as aspects of our modern world are dependent upon water resources, from energy to agriculture. Ms. Zhang presented the results of her hydrological and climate models, based upon atmosphere and radiation mechanisms. Across all timescales, from day to day to decadal, it is likely that already wet environments will get wetter and thus will proliferate an increase in the frequency of extreme events. The seminar led by Ms. Zhang was very technical, mathsy, and a bit over my head. But ultimately there was a very clear message. And I think personally it's becoming more and more important for people to realise how widely climate change can impact on us. Water is an essential to many. And I don't think people realise, despite seeing clouds and rain every day, how intimately linked water is to our climate. With the increase of extreme flooding and extreme drought, problems are just magnified on top of already established problems. Thank you for getting to the end of this episode. If you enjoyed listening to this topic and would like to find out more, I have cited some further reading in the description. If you're interested in geological or geographical sciences, then feel free to look at any more of the episodes in this series, and I'm sure there'll be something. Without more to say, thank you for listening,